students. So far we have learned about magnetic effects of current. So let us try to solve problems from magnetic effects of current. So the first problem, a charge of 2 microcoulomb moves with a constant speed of 2 into 10 power 6 meter per second along the x-axis, positive x-axis. The magnetic field B is given here. So you are supposed to find the magnetic force. So charge, let us write what are the data given here. So charge is given to us, which is 2 into 10 power minus 6 coulomb, and speed is given, which is 2 into 10 power 6 meter per second. That too, it is moving in the positive x-axis. So let me write the direction as well. It is I-cap direction. And the magnetic field is given as 0.20 j vector plus 0.40 k vector Tesla. Alright. So you have to find the magnetic force. So from Lorentz force law, we know that Q into V vector cross V vector, right? So just to please substitute the values, you know what's the value of charge, which is 2 into 10 power minus 6. So velocity is given as 2 into 10 power 6 I cap, right? So let me use a different color. So cross product of 0.20 J cap plus 0.40 K cap. So this is what the electric force is. So now please, you know the vector product. So just to multiply it, you can have the answer. Let me take the constant terms outside. Outside you have 10 power 2 into 10 power minus 6. So this is nothing but 2 into 0.2 times I cap cross J cap, right? Plus here we have 2 into, we have a 10 power 6 also I can take outside, right? So we have 2 into 0.40 into I cap cross K cap, right? So now you know this value, which is nothing but zero point 0.4, we have 0.8, and outside we have 2. So just to multiply that, you have 0.8 times, this turns out to be K cap, right? Here we have a minus, because K cap cross I cap is positive J cap. So this, because it does not obey the commutative law, I hope you know that this is 1.6 times J cap. So this is the corresponding force. Just it's a kind of a direct question, right? We shall move on to next problem. Let me erase this. If you want to copy, please pause the video and copy it. Right. So moving on to next problem. So a proton, a deuteron, and an alpha particle which is moving with equal kinetic energies enter perpendicularly into a magnetic field. If RP, RD, and R alpha are the respective radii of the circular path, find the ratio of RP by RD and RP by R alpha. You know that once any alpha particle or any charged particle enters into a perpendicular magnetic field, it will take a circular path, right? So because of the Lorentz force law, right? So now the radius is given as RP and RT and R alpha are the radii of the particular charged particle. Then we have to find the ratio of RP by RD and then RT by R alpha. So let us write down the formula for R, the radius. This is given as mv by qp. So this radius clearly depends upon the mass and charged particle, as well as it depends on the magnetic field. But the question is given here is it moves with an equal kinetic energy. But we don't have any information about the momentum or the velocity. So let me convert that in terms of energy. You know, momentum, which is nothing but mv, I can relate with 2me. Shall I? I hope you know this relation. So just substitute back here. So by just substituting 2me divided by qp. So now E to B magnetic field remains the same. So the only variables are going to be R is directly proportional to root of m divided by q. So you know mass and the for mass for the deuteron, proton, and the alpha particle is quite different from one from another. Let us find out that. So which is md, which is 2 times mp. You know that, right? And qp, which is equivalent of qd. This is what about deuteron with respect to proton. Now let us find out the relation for the mass of the alpha particle, which is 4 times mass of the proton, and correspondingly charge of the alpha particle, which is 2 times qp. Right? So these are the information we know. Just substituting back, we can get the answer. So RP by RD, which is nothing but, so here you have MP, right, divided by QP. Here we have MD divided by QD. So we got B in terms of D or MD in terms of this is nothing but so QP divided by or times the root of MP divided by QP. This turns out to be root 2MP. Shall we? So let me cancel these terms. So RP by RD, which turns out to be 1 by root 2. So similarly, we can do the same for RP by R alpha as well. So RP by R alpha turns out to be root M alpha, sorry, MP divided by QP. Here we have root M alpha divided by Q alpha. So please substitute the known values root MP. Here we have 2 times QP, right? Divided by here we have QP. Here 4 times, root of 4 times MP. I can take 4 outside, which is 2 times MP. Shall I? Root. So let me cancel the terms over here. So if I'm cancelling, I'm getting 1. So the ratio of RP by R alpha turns out to be 1. Right? Yes. So let me erase this completely. Moving on to next problem. Yes. A particle, a particle having a charge 20 microcoulomb and mass 20 microgram moves along a circle of radius 5 centimeter under the action of the magnetic field. So basically one charged particle with a charge and a mass which moves with the circle that radius is given here under the action of the magnetic field, right? So when the particle is at a point P, a uniform electric field is switched on and it is found that the particle continues on the tangent through P with a uniform velocity, find the electric field. So what they are saying, so here let's say we have a uniform magnetic field. Let's say it is constantly going inside the ball and a charged particle enters this field which is perpendicular to it and it takes a circular turn of the radius is given here, right? So once the electric field, let's say particle might be anywhere, let us assume the particle is here. This is a point P, the particle is right now, this particle is here. Now let me switch on the electric field. So by switching on the electric field, we found that the particle continues to move on the tangent. Let's say we have a draw, if we draw a tangent like this, it continues to move like this, right? So if so, and it moreover it moves with a constant or uniform velocity, then what could be the electric field? This is the question. And you know that when does the particle moves with a uniform velocity? When total force acts on the particle turns out to be zero, right? So once if that's the case, we can expect the particle will move with the constant velocity or uniform velocity. So at this point, what are the force this particle it may experience? Because of the magnetic field, it may experience a magnetic force which is basically pointing inward direction, right? And moreover, once you switch on the electric field, correspondingly, it will experience the electric field as well that will point in the vertically or opposite to the magnetic force, right? This is our electric force and this is our magnetic force. So now if it wants to move along the tangent, that too with a uniform velocity, so your magnetic force must be balanced by the electric force, right? So you know what magnetic force is, which is QVB. Here we know which is QE, right? So let me cancel this Q here. So surprisingly, you know, this V is nothing but this is the velocity selector. We have got the velocity, right? This is E by V. Now we have to find the velocity, yeah, sorry, electric field, which is V times V. Shall I write like this? But magnetic field is given to us, but we don't know about the velocity. How can we get the velocity? Just by radius is given here, which is mv by qb, right? So from this we can able to find v, so which is qbr by m. Shall we? All values are given here. The charge is given to us, mass is given to us, magnetic field, the radius also given to us. Just by substituting it, you may have 50 meter per second. Please, if not, let me know. So this is the velocity of this particle. So now what I'm going to do, I'm going to substitute back here by substituting as the electric field turns out to be 50 volt per meter because magnetic field is simply 1, right? Just by multiplying 1, you don't have any change in the value, right? Just electric field turns out to be 50 volts per meter. So this is the answer, right? I hope it is clear. Let me erase this. Moving on to next problem. Right. A beam of protons, we have a beam of protons here. which will move with a velocity of 4 into 10 power 5 meter per second, enters a uniform magnetic field of 0.3 Tesla. The velocity makes an angle 60 degree with the magnetic field, right? So find the radius of the helical path taken by the proton beam and the pitch of the helix will be, right? So here the same, exactly the same case, only the difference is velocity is no longer perpendicular to the magnetic field, but it makes certain angle, let's say 60 degrees. So in that sense, how can we find the, so once it makes it will neither makes an angle 90 degree or nor makes an angle 0 degree, then we have two components of velocity. That is one along the x-axis and one along the vertical axis, right? So by resolving it, we can find out the velocity as well as we can find the radius as well as we can find out the pitch. Pitch formula already we had discussed. Pitch is nothing but V parallel times time period, right? So V parallel, which is nothing but V cos theta, and V perpendicular, which is nothing but V sin theta. Shall I substitute like this? So since the values of V and the theta is given here, so just find out the parallel and perpendicular component, which is 4 into 10 power 5. Here cos is nothing but 50. So cos 60, which is nothing but 1 by 2. So parallel component of velocity, which is nothing but 2 into 10 power 5 meter per second. Shall we? And V perpendicular, which is nothing but 4 into 10 power 5, and the sine 60 turns out to be root 3 by 2. So we are getting 2 root 3 into 10 power 5 meter per second. Shall I tell like that? So we can able to find the radius, which is nothing but the formula V mv by qb. Which V I have to take? I have to take the perpendicular V, right? Because that will provide the helical. That perpendicular component makes the particle to move in a circular path, right? So I have to include the perpendicular component. So R turns out to be, so since the protons are moving, mass is nothing but 1.67 into 10 power minus 27 into velocity perpendicular, which is 2 into root 3 into 10 power 5 divided by charge is nothing but 1.6 into 10 power minus 19. Magnetic field is 0.3. So by substituting all the values, we have radius turns out to be 1.2 centimeter. So please check. If not, let me know. This is value turns out to be 1.2 centimeter. So now let us find out the pitch. So pitch is nothing but the time period we need to find out, which is 2 pi r by v perpendicular, right? Because time period which tells you the complete one revolution, right? So if the particle has to make a revolution or to form a complete circle, that time you have to take the v perpendicular component. So please substitute and you can have the answer. Time period, which is 2 into 3.14, radius, which is we have to find out the radius. We don't have any information just now before. I'm sorry, we got right. So 1.2 into 10 power minus 2 divided by the perpendicular, which is 2 into root 3 into 10 power 5. So by solving this, your time period, and you have to multiply this time period value, and then you have to multiply with the V parallel, which is 2 into 10 power 5. So the pitch turns out to be 4.4 centimeters. So please check. If not, let me know. Right. So moving on to next problem. All right. So can you see this? A magnetic field 4 into 10 power 3 K cap Tesla exerts a force on the particle having a charge of 1 into 10 power minus 9 coulomb and going in an xy plane. So find the velocity of the particle. All right. So let us try to